we're going to look in 6D, we're going to look at finding the equation of the line, either from its intercepts and finding the gradient. So what I was explaining yesterday was what we're going to head into when we do the next topic is like bivariate data. And what we will have is like scatter plots like this. So they're like dot plots or whatever. And you end up getting like a line of best fit. So sometimes you're going to get a question where all of this has been done and that line is there. And they're going to ask you for the equation of that line. So because it's a straight line, we're going to say it's going to follow this pattern here. So we're saying that the B is like our gradient, isn't it? Yeah? So if the B is like our gradient, you can use that y2 minus y1 over x2 minus x1 scenario. So all you do is go and read off 2 points on your graph that you can see on the line, and you can do that and you could find the B value. And the other value here, the A, that's the Y-intercept. So sorry, if I drew my line a little bit further, as long as it says 0 down here, you could read off your A value because it's where it cuts that axis there. All right, so that's what we're doing this little bit today and tomorrow, yesterday and today, sorry. We're just doing it because we need you to remember these things when we're doing that part in the next topic. So let's have a look at what they say here. So finding the equation of a straight line from its intercepts and slope. So they said first identify the y-intercept. So if we're down here, we can see, can you see there's 0 and there it cuts it there. So we know that A is equal to 2, yeah? And then the next step they're saying too is use 2 points on the graph to find B. So let's go find ones that, so I'm going to zoom mine in a bit so it's a bit easier. So let's go find 2 points where this graph crosses a thing. So I reckon that one's pretty nice and neat. So it is x is 1.5, would you agree? And y is 4, so there's 1 point. And I might use this one up here because it seems nice, it's gone through it. So I might use 5 and, is it 9? Yeah, you happy with that? So when we go to find the B, I'm going to use that y2 minus y1 over x2 minus x1. So I go label these guys, I might call that x1, y1, x2, y2. And I'll plug that into the calculator. So I've got 9 minus 4 over 5 minus 1.5. So what do we get? We get 5 over 3.5. So just quickly do that on your calculator. Okay, so it comes to 1.43. I've just rounded it. So now you've got those two values, you can write the equation of this line. It'd be y equals 2 plus 1.43 times x. Okay, so when you start to get things like examples where you think, so this might end up being, I don't know, cost over time or something like that. When you start getting scenarios, you just got to remember to change these things to those variables, for example, yeah? So that's the only difference you've got to do. All right, so they've asked us to find the equations of these lines. So I'm sorry, I'm going to zoom. I'll move him over there. Zoom this in a bit. All right, so we said the first step is to get the y-intercept. So I'm going to look. Now, see how I'm checking all the time that that's 0. Why I do that for? Because sometimes next year, they'll do this. You'll have a graph, whatever, with the dots again, and you'll have a line, whatever, but they'll say that this is starting on 10, 20, 30, okay? If that's like that, this is not the y-intercept. Why is it not the y-intercept? Because it's not 0 there, yeah? For it to be the y-intercept, you actually have to be on the 0 line, yeah? So just be careful. That's why they're not telling you, because you're not going to get them in these questions this time, But that's what they get next year in year 12 when they get caught on it and they write the wrong thing. So I'm just trying to tell you to check this every time so that you're not going to get caught next year. So I know it sounds funny because I'm saying it and every time it's 0, but that's why. So we go look for the Y-intercept. So yes, I've said that that's 0. So I can read that off as the Y-intercept, which to me looks like 200. Are you happy with that? So I'm going to say A equals 200. And now I'm going to go find B, and I'm going to use 2 points it goes through. So I like that one. It looks like it goes straight through it. So it's 4 and 600. And I'm going to find another one. I might use this one. Doesn't matter which 2 you use as long as the line's going through it, which was 16 and 1800. Okay, so we'll use the y2 minus y1 over x2 minus x1. Pop your values in. So I might call this 1800 minus 600 over 16 minus 4. So that will be 1200 over, is that 12? So it equals 100. Yeah? So therefore our equation, we could write it as y equals 200 plus 100 times x. Now, is that what the variables are saying though? What have they called it? Oops, sorry. They've called it volume and time. So really, I've got to write volume and in litres equals 200 plus 100 times the time, and we write minutes. We just put the units like that. Okay, so we've got to be careful with that. All right, so let's go do the next one. So the next one, let's have a look. We'll find the y-intercept first. So I've checked that that is 0, which I'm happy with. And it's crossing in between, so 25,000 and 30,000. So what do we want to say? 20. It's okay if you're roughly. If they give something like that, you can be rough. So I'm going to say 27.5. Is everyone happy with that? I'm roughly. If you would like said 28, we're going to give it to you, yeah? So then if we write, then we've got to find the B. So the B value is doing y2 minus y1 over x2 minus x1. Okay, so let's go find some 2 points. So they've even marked some, so thank you. We might use them. So I might use this one. So you write the 5 and 15,000. And I'm going to use this one, 9 and 5,000. So I'm going to call this one x1, y1, x2, y2. So I've got 5,000 minus 15,000 over 9 minus 5. Now, looking at that line, how it's going downwards, so what do we expect the gradient to be, a positive or a negative? Yeah, negative. There's things like that that you should look out for just to make sure. So I've got negative 10,000 over 4, yeah? Which equals, what's that? Negative 2,500, is that right? Yeah. So that's things you can check. So just see how I then, because that's what I paused myself to do. I looked at my numbers and I thought, oh, I'm going to get a negative, and then I flicked back to look at the graph and went, oh yeah, it is a negative gradient. So see how I checked my work with not doing my sum again. I looked at some other point of evidence to try and check that I'm doing the right thing. That's what you got to do. That's how you pick up your mistakes, and that's how you get a perfect score. Yeah, it's the difference of those things. All right, so we've got to go write our equation out now. Now they don't have, what is it? It's value this time. They don't have y. So value equals 27,500 minus 2,500 times time in years. Okay. All right, so let's do the last one. So once again, we're going to find the y-intercept first. So I've checked that that is 0, and that is. So I'm going to go with that. And what do we reckon that looks like? 18? Good. So we're going to say the A, or the y-intercept, is 18. Now we're going to find the B value. using we'll use this formula. And so we've got to go find 2 points that it crosses. Now, what I want you to be careful with, you don't want to use those black dots unless it's on the red line. So we're looking for points for the red line. So I'm going to use our intercept. So what's x at our intercept? 0. So I'm going to use that one because we're saying that goes straight through. And I'm going to use this one because it's on the red line and it's a little bit easier to see. So that one's 5 and 25. So it has to be a point it has to be on the red line. It doesn't have to be one of those dots. I've picked those because they're on the red line. It just has to be two things, like a coordinate where the red line crosses through. Okay, be careful with that. So I might call it, so I'm going to say 25 minus 18 over 5 minus 0. So what's that? 7 over 5, which we can leave it like that, or what can we say? That's what is that? 1.5, is it? No, is that right? Yeah, and 2/5 is 1.4. Is that right? Yep. So when I go to write out the equation, so I'm going to write it down here. This one's actually velocity in meters per second equals 18 plus, is that a positive gradient? Because I've got it, that's what I worked it out, and that is, so time in seconds, whatever. Okay, done.